Alright, so in this video, I'm going to discuss the deepseek-r1 paper with you all and why there's so much hype around it. So let's get started. Alright, yeah. So the authors have introduced a way through which we can bypass. They have tried to bypass the fine-tuning part in the LLM training. And let me just give you some overview about what else pre-training, what is fine-tuning. So first of all, when we had like in 2020s or in 2019s, when we used to have GPT models or the models which were able to generate text on the basis of whatever input we give to them, they were not that much good in responding to whatever text we gave to them. And this is because at that time there was no fine tuning in those models. And let me just give you a quick overview to you about what is pre-training. Pre-training is basically training of a particular model on a large corpus of dataset. Let's say we have a very large dataset, something like this, that is related to news, that is related to all the current affairs going in the world, everything and anything, history, social science, computer science, all the topics, whatever we can find out, we have collected that over some place, and then we are like giving a piece of text to our LLM, and then we are trying to train it over to generate the next text uh, through that. So this is known as pre-training. For example, let us assume that the model, our training data has some Wikipedia articles, and we are giving input to the model something like the, and then now we want the model to predict new, and then after the new will be acting as input, and then the model should output budget, so something like this. So we have sort of trained our model on a large corpus of data, and now it is fairly able to generate or get the semantics of the language, and it's basically now good to predict the next token. But there's a missing part. Although it is able to generate new tokens, new text based on the input, which is also known as prompt, it is not good in responding to the user's query. This is because these texts are just normal articles, or the model has learned to only generate next article or token with the help of this dataset. We don't have a highly curated, detailed, good data, because of which model would be able to generate a response which we would like, or which is the desired response through which it can actually uh, responses to us in a way chat GPT responds. So these models were not like this, right? So that's why these models are known as pre-trained models, and these are basically trained over the whole internet. But still, the missing part is fine tuning, and in fine tuning the weights of the pre-trained model gets adjusted in such a way that now it is more coherent or more good in responding to whatever question we ask, because the in fine tuning part we have a curated data set which contains the questions as inputs and the responses as outputs. So now the model actually learns how to generate text based on the user's queries because of this data set used in fine tuning part. But this fine tuning is expensive, and let me give an example why it is the case. And it is also not always possible that we would be able to find a data set of our desired needs. For example, let's take the field of medical. In this, let's say we want to make a LLM which is good in generating, or which is good in replying to whatever question we ask, which is related to field of medicine. So uh, most probably the model would not be able to generate a good reply, because it is hard to find a data set which is related to medical conditions, or which is related to medical treatments. That's the case, and that is why fine tuning is expensive, or there's problem in fine tuning part. And what the researchers in this paper have tried, they have like tried to completely bypass this whole fine tuning part, and they have incorporated reinforcement learning to this pre-trained model, which is in our case is deepseek v3 base. And through this they have tried to like generate a model, or a model or a LLM which is equivalent to the model during which is equivalent to the model of when we used to do fine tuning over it. Yeah. So this is the first model which the researchers have released in this paper, which is deepseek-r1, and the second method has some sort of fine tuning, and on top of it there's reinforcement learning involved. All right, so let's go through the paper. Yeah. So they have said that we introduce our first generation reasoning models, deepseek-r1 and deepseek-r1. And deepseek-r1 is a model trained via large-scale reinforcement learning without supervised fine-tuning. So they have completely bypassed it, and it demonstrates remarkable reasoning capabilities. Now, what does one mean by reasoning capabilities? It means that we want the model to also reason why it is answering in a particular manner. Like when we solve a particular math problem, we reason ourselves like why we are putting this in a particular formula, or why we are solving a particular problem in this way, or why we are implementing this. So we are constantly thinking why we are doing a particular step, and we want to incorporate that same thing in our model also, and that is done via reinforcement learning. Okay, the deepseek-r1, and but there was some issues with deepseek-r1, and which was poor readability, and as well as it was mixing two languages or multiple languages in its response. And to address these problems, they trained one more model, which was this model 2, which involves some fine tuning and reinforcement learning on top of it. So yeah, they try to incorporate reasoning capabilities in the model just by using RL. We have discussed this, and yeah, their goal is to explore potential of LLMs to develop reasoning capabilities without any supervised data, focusing on their self-evaluation through a pure RL process. Okay, cool. Specifically, we use DeepSeek v3 base as the base model and employ GRPO. One more special thing about this model is, or about this paper is, that they have used RL algorithm GRPO, which was also developed by these researchers only in another paper which is named as DeepSeek Math. And they found out in DeepSeek Math paper, they found out that that model was very good in the questions related to math, so they implemented it in their main model. Yeah, basically that DeepSeek math model was very well in replying to questions related to mathematics. It was able to reason, and then it was giving reply. So yeah, it was good in that sense. Yeah. Also, one more thing which has been done in this paper is that they have used one technique, distillation, which is basically something like this. Let me explain it. Let's say we have a very big model, and let's just assume that this is deepseek-r1 model, and we have some input and it generates some output, which is very good. But the main problem with this deepseek-r1 model is that it's very huge, it's very large. Just for uh, giving you an idea, that the main deepseek-r1 model, which has around 671 billion parameters, is of size 400 GB. So it's very huge. We won't be able to use that in our local computers or even on servers. It would be very expensive to run even a single query on this model. So what they have done is they have used a technique known as distillation, in which we force the models which have small parameters or which are small models to generate the same output as these bigger models when a query is given to it, and this query is also same. So we generate a data set over this, and now we force this to learn the same data distribution, or to learn the same way uh, through which it is able to respond in a similar manner to the bigger model. So this process is known as distillation, and the researchers have said that they have implemented distillation with the help of some smaller models, which is llama and quan models, and the bigger model which is used for this is deepseek-r1. All right, and yeah, they were successful in this distillation process. Yeah. Okay, post training, we directly apply RL to the base model without relying on SFT, and this approach allows the model to explain chain of thought. Yeah, so what does this RL process helps in is that the model is now able to think why it is answering in a certain manner. All right, it's just not like, obviously it's next token prediction, but now we are like trying to train a model, or we are like trying to make the model to think why it thinks that the next token will be some particular token. I think it might be complicated to understand what I wanted to say, but let's hope you are able to understand. And notably, it's the first open research to validate the reasoning capabilities of LLM that can be incentivized purely through RL without the need of SFT. Yeah. So, and by the way, this deepseek-r1 is comparable to the OpenAI's O1 model. Here they are talking about the distillation. I have already explained that, and overview that deepseek-r1 which applies RL directly to the base model without any SFT data, and in their main model, which is deepseek-r1, yeah, in this model deepseek-r1, they have like taken a couple of steps in which first of all they fine-tune the model over a very small data set, fine-tune the base pre-trained DeepSeek v3 model over a small data set, and then they apply RL over it. It's something like this. Yeah, and then they get a model which is very good in responding to the user's query, and it also thinks while responding to that query, and that thinking part involves why it is responding in a certain way. So that's the main thing. All right, yeah. Regarding this algorithm which they have used is something like, uh, first of all, they generate a lot of responses for the same question, and then there's a particular reward system which gives reward to the model if the answer is more correct, or if the answer is more relevant to what we wanted as the desired answer. And if it's not related to the desired result or the desired output, it is penalized for that, and then the parameters of model adjust itself in such a way that they don't predict the tokens in a way such that it get penalizes. It always wants to get rewarded for the token it generates, or for the output it generates. It always wants to get rewarded for that. So basically we are like forcing or training the model to give good rewards, give better responses, or to give responses in a desired manner such that it gets rewarded for that. And that's how the weights in the model gets adjusted. And then here they talk about the whole formula, or how the whole RL algorithm works, and yeah, and how the reward is working in this RL algorithm. So let's go through this. So the reward is basically rule based reward, and it involves no neural network. So basically the reward system also used to involve some sort of neural network. But in deepseek-r1, in this paper, they have completely abolished that, and they have like kept some rule-based rewards in which they reward the model if it responds in a certain way. And here's the more detail about it. So let's say for a lead code problem, if the code which the model generates, if that code is being able to get compiled, and then that code passes all the test cases, then the model is rewarded. And similarly, format rewards, and in format rewards, it's something like the model should also output its thinking, that why it responded in a certain way, or why it responded in that way only. So it should also output that. Like if someone is saying good morning to me during night, so I should think that they might be saying in some sort of sarcasm to me, or they might not know that it's night right now. Yeah, so these kinds of things can happen, and after that I would like respond to them, for example, yeah, good morning, or I would correct them, no, it's not morning, it's night, so you should say good evening or good night. Yeah, something like that. So here the researchers want, or the authors of this paper want, that the model should also explain why it is responding in a particular manner. So that's the whole crux of it. Yeah, and the template which they have used is something like this. The a conversation between user and assistant. The user asks a question, and then blah 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 blah, and then the reasoning process and the answer are enclosed within think tags and answer tags respectively. Think reasoning process here, answer here, something like this. Yeah. What else is left? Yeah, so one more thing, that this graph is also being discussed a lot. So what this graph says is that the average response length of deepseek-r1 on the training set during RL process. Deepseek-r1 naturally learns to solve reasoning tasks with more thinking time. So there is somehow model has learned the way that the more it thinks, the more text it outputs in the think tags, the more it is rewarded. So that's why the response length of the model is going longer as we train it over time. And I don't know, but this might not be correctly right here, because it's not always the case that the if the model has a longer sequence of text present between the think tags, then it would be right. And basically it has learned a way to get rewarded if it is generating more text between the think tags, so it's not that right. And I was going over a tweet by a guy. Let me just go through that tweet quickly, in which he said that the less number of think tags present, the text between the think tags present, the more accurate the answer is. So he ran an experiment and he came to this conclusion. So let's go over his tweet. Yeah, and all the reasoning models, the wrong answers are much longer while the correct answers are much shorter. Even on the same question, when we rerun the model, it sometimes produces a short, usually correct answer or a wrong. Basically on this I would like to and he proposed a solution in which he said that he said something it's not that important, but yeah, by doing this he was able to increase the accuracy by 6-7%. So you can read this tweet in detail, and he ran this experiment only on dataset related to math. Yeah, on problems related to maths. Yeah, so I'll add the link of this tweet in the description, and you can read it in detail. So let's get back to the paper. Yeah, so yeah, what I want to say that it's not always the case if there's longer sequence of text present in the think tag, so the model will be correct. So it's not that case. And also one more thing, there's not a data set in which think tags are provided. We are just like trying the to ask the model to do that, and it is somehow able to do this because of the reinforcement learning part. There's no data set on in which we have for deepseek-r1 in which we have used or in which we have trained the model over a data set which include the think tags. So it is like it is able to generate organically or naturally the reasoning in the think tags, and this is what I find the most interesting thing in this paper. Yeah, yeah. So this is something like the aha moment of deepseek-r1, and I think it's like test time compute, which I already discussed with you. Like the model is thinking why it is responding in a certain way. So they discuss this thing only in this paragraph, that the deepseek-r1 learns to allocate more thinking time to a problem by re-evaluating its initial approach. Rather than explicitly teaching the model on how to solve a problem, they simply provide it with the right incentives and it autonomously develops advanced problem solving strategies. Yeah. So let's go over this thing quickly. So the model was given a math problem and it solves it, it tries to solve it, and here it has come a way which is overly complicated, and then the model reevaluates whatever it was thinking or whatever it was generating, and then it corrects itself by saying, oh wait, there's one more easier way to solve this problem, and let's try to solve this problem again. And this is the aha moment. So the model in the think tags generated, wait, that's an aha moment I can flag here by itself. There was no data set involved in this or no text involved in this which contained something like this. So it is able to learn this by itself. Yeah. So now let's come over this part. uh, I hope that this part is clear. I tried my best to explain, but even I'm a newbie. So uh, and now let's come to the main model, which is deepseek-r1, in which some fine tuning is also involved, as well as this RL is involved. So deepseek-r1, and why deepseek-r1 was not good, because since there was no fine tuning, there were many times that model was mixing up language, or it was not able to generate a good response. So but that model was good in reasoning, but it was not able to generate a good or desired response. That's why the researchers incorporated or tried to incorporate a very small part of fine tuning, and then start reinforcement learning over it. Yeah. Yeah. So in this section, they discuss that inspired by the promising results of deepseek-r1, two natural questions arise. Can reasoning performance be further improvised or convergence accelerated by incorporating a small amount of high quality data as a cold start? How can we train a user-friendly model that not only produces clear and coherent chain of thoughts but also demonstrates strong general capabilities? So yeah, in deepseek-r1, it was fairly able to think by itself, thus giving like it has good reasoning capabilities, but it was not able to respond to general questions, something like hello. So yeah, so that's why we needed, or it was able to generate hello. That's a wrong example which I took, but something like hello, is it night on morning, something like this. So that's why what researchers try is that they first of all take DeepSeek v3 base model, and then they fine tune it over a very high quality data set which contain the think tags and the response, and as well as the question, which is obvious. And then they fine tune this DeepSeek v3 base over that small data set which they have collected. All right. And I have not gone through how they collected this data, but yeah, you should read it to know. I don't know about it. And then yeah, and then after fine tuning this over that small amount of data, they apply the reinforcement learning part over this fine tuned model, and then they uh, use the checkpoints of this model to generate a data set. It's something like this. After fine tuning, let's go through this. After fine tuning DeepSeek v3 base on the cold start data, I mean they have fine tuned a small data set which contains the reasoning part also. They apply the same reinforcement learning training process in the deepseek-r1. All right. So now we are at this step. Currently we are here. All right. And now what they are doing is that, and yeah, also to like remove the issue of language mixing and all, they introduce some rewards that it's something like that. If you will just give reply in one type of language, you will get rewarded, or if the input prompt contains two languages, so the response should also contain the same proportion of the languages as present in the input prompt or in the question which is being asked by the user. So they have like introduced a couple of more new rules. Now, when the reasoning oriented RL converges, we utilize the resulting checkpoints to collect supervised fine-tuning data for the subsequent round. Unlike the initial cold start, which primarily focuses on reasoning, this stage incorporates data from other domains. Okay, so for now they are like generating a new data set from the model which they have trained till here, and also some general data. General data is generated so that the model is can be used for everything. All right, for general tasks also. Yeah, and then using the data set which is being generated by the model which is being present here, they fine tune the DeepSeek v3 base model for 2 epochs, and the data set has something around 800,000 samples which is being generated from here. And then now the things are not much clear to me at this moment, but and then something is like, after the fine tuning of the DeepSeek v3 base, they implement reinforcement learning on it so that the model is fairly able to answer, or it is fairly able to respond to any kind of query. So it can be like now used to generate or write a mail, which is a fairly low reasoning task, and it can be as well as able to solve now coding problems or like solving math problems which like involves a good amount of reasoning, which needs good amount of reasoning capabilities, which was like missing from the current LLMs. Yeah, so let's read this. To further align the model with human preferences, we implement secondary reinforcement learning stage aimed at improving the model's helpfulness and harmlessness while simultaneously refining its reasoning capabilities. Specifically, we train the model using a combination of reward signals and diverse prompt distributions. Okay, so like now they are trying out various things, like they are they have written different prompts, and there are several reward rules also there, so it's a bit unclear. For reasoning data, we adhere to the methodology outlined in deepseek-r1, which utilizes rule-based rewards. Okay, yeah. For general data, we resort to reward models to capture human preferences in complex and nuanced scenarios. Okay, so here I guess they have incorporated RLHF, which is reinforcement learning with human feedback. So there might have been a human uh, in which he, whether it might have been asked from that human, or human might have labeled whether he was satisfied with the response which has been generated by the LLM or not. So for general data there's RLHF, and for the reasoning based data there has been rule based rewards. Okay, all right. And now the distillation process is discussed, in which this R1 model, which has been trained right now, the the reasoning capabilities or the outputs of now R1 is like incorporated into small models. So that's what distillation is all about. Yeah, yeah. And they tried one more thing, that they incorporated reinforcement learning on small models itself, and they found out that model distillation is giving more better accuracy, or distillation process was more powerful than implementing RL on small data or on small models. They have discussed this. Yeah, and yeah, that's all. And although this, they have discussed some of the limitations of this. So one limitation which I found out is that it's not necessary that if the model is generating longer responses, then then it's right. And one more thing which I am currently unclear is that how they are like in deepseek-r1 0. Like I do know that in deepseek-r1 there's RLHF involved for general questions, but I don't know if in deepseek-r1 how they are like incorporating reward for normal questions or for textual based questions. What is the rule for rewarding? That's a bit unclear to me right now, but anyway, we'll know as time passes by. Yeah, so we were here, limitations of this. So in general capability, currently the deepseek-r1 model falls short of the base model in tasks such as function calling, multi-turn complex role playing, and JSON output. So basically, there's a bit, this model is a bit behind the main pre-trained model in some general tasks. It mixes language prompt engineering also, so this might be important for people who are pulling the model from Olama. So yeah, it is sensitive to prompts. So well, every model is sensitive to prompts. And yeah, one more thing which I found interesting is that few shot prompting degrades the performance of this model. So the authors are recommending users of this model to directly describe the problem and specify the output format via zero shot prompting for better results. Yeah. Is there anything which I want to discuss? Let me check. Yeah, there's nothing. Yeah, so this was all about DeepSeek R1. I guess I was fairly able to explain it. If not, let me know in the comments. Yeah, so this was all from my side.